Okay, let's go. Today we've got the product and quotient rule. What does that mean? Well, on some of the problems from day 13, you may have seen something like this. Let's suppose f of x is equal to x times x squared plus 3. Okay. Simple cubic function, but it's not multiplied out. And I might ask you, what is f prime of x? What's a derivative, in other words? A common mistake that people make is they relate that phrase that I kept using over and over again. Remember the one that says the derivative of the sum is the sum of the derivatives? We did the same thing with limits. It does not apply for products and quotients. In other words, this derivative is not the derivative of x times the derivative of x squared plus 3. Okay, which would be, by the way, 1 times 2x. That is not right. Now, based on what you currently know, how would you find that derivative? Multiply it out. Okay, good. Distributive property, you turn this into x cubed plus 3x and then go crazy and find the derivative. Okay, good. However, what if I said to you, I would like you to find the derivative of this. That's not good. I'm sorry? You could use Pascal's triangle. Do you know Pascal's triangle on the 13th level?
No.
Good, because I would be worried about you if you did.
Something there you would know.
He probably does. But we'll ask him when he comes back. If he does rattle that off, I'm leaving. I'm done. I'm retiring early.
Me too.
Right, and talking to his counselor, because that's not a good idea. Okay. This is not an easy thing to do. We're not going to quote unquote multiply that out because we're normal. Okay? So we have to find other ways to do it. That's what the product and the quotient rule are going to do, is allow us to do derivatives of functions multiplied together. Okay, but for practice, show me that you can do that. Go ahead. This does not require the product rule and quotient rule. It's just a straight up power rule problem. Make sure you're paying attention from yesterday's work. Or I should say Monday's work. Today's Wednesday, right?
Yes.
How are you wearing a sweatshirt? You're insane. Okay, we good? Problems? Nope. Okay, now you use yours.
This is like 6 minus 1. Negative 6 minus 1. What's negative 5? Actually, it's like 12 times 1.
Oh shoot.
Good catch.
Oh no.
6 minus 1. Negative 6 minus 1 equals
Is it?
7. Good.
You need an X though.
Thank you.
Is that what you're going with?
Yeah.
Do we agree?
Yes.
Beautiful. Let's give it up for Nadia.
Woohoo!
All right, so she initially made the mistake of doing negative 6 minus 1 to get negative 5, which happens all the time, but it should be negative 7. And the square root of x is the same thing as x to the 1/2. Brought that down times 12 to get 6 and reduced it by 1 to get negative 1/2. And again, at this point in time, we're okay with those negative exponents. Later on, we'll work on getting rid of those negative exponents because those would be a bad thing. But we got a lot of other things to worry about before we get there. Okay? Today's lesson, aside from getting the product and quotient rule, has a ton of examples because I think the examples will illustrate illustrate the ideas the best. Okay, so today we're going to talk about the product rule. We're going to talk about the quotient rule. We're going to talk about higher order derivatives. That's the same thing as the second derivative, the third derivative, the fourth derivative, et cetera, et cetera. And you should eat more vegetables. That's true. Whether you like them or not. Okay. All right, so here's the product rule. Another example for you. Please find the derivative of that.
Oh, yeah.
It's already there.
Good job, everybody.
Almost.
I'm an idiot. Guess I believe it the wrong. All right, so let me try to recover from this. I multiplied it out using the FOIL method, and then took the derivative and was good to go, which will work. But as I mentioned earlier, what if the functions get too big and scary, and you don't want to multiply them out? We have this thing called the product rule. Did I put this on there too? No? Okay, good. So, how to find the derivative doing the product rule? I'm going to talk you through it while I'm doing it. You have two terms, first term, second term. The derivative of the first times the second plus the first times the derivative of the second. Whoops. Done. And I'll give that to you again in a second. But that looks very different than that. Okay, negative 24x squared plus 4x plus 15. Why? Because I didn't multiply that puppy out. Should you multiply that puppy out? Yeah, probably. So I get 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. Negative 24x squared. That takes care of that and that. I've got 24 plus 4x. That takes care of that, that, and that. Plus 15. Is that the same thing? It is. Oh, good. Okay, same. So there is the actual product rule in calculus speak. Now, they have it differently than I do it, but it doesn't matter. It's the same thing. They're doing the first function times the derivative of the second plus the derivative of the first function times the second. It doesn't matter what order you do it in, you're going to get the same results.
We go back to it one more time.
This guy? Good? Okay. First times the derivative of the second plus. And that plus is important because when we get to the quotient rule, just to make things more complicated, the quotient rule is minus when we get into it. It'll make sense in a little bit. Okay, so do that. Notice I said use the product rule. Don't cheat and multiply that out. Did I put this on the slideshow too? Oh,
Yeah. The derivative of the first times the second plus the first times the derivative of the second.
That makes sense.
What's the derivative of the second?
Wait, is it the derivative of the first times the derivative of the second?
derivative of the second,
It's just that one.
Okay, so you don't need to do
It's first term.
Times
three
times
cubed
actually
plus
So you take
3x squared plus 7
times the second. Then you take the derivative of the x. Then you take the first times the derivative of the second.
Derivative of the second.
plus 1
Derivative of the first.
is 4x is 9x There you go. Oh yeah, yeah. 4 cubed plus 9 squared plus 14 plus 21. Yeah.
Wait, where'd you get that 14?
Okay, we good?
It's 7x plus 7. Yeah.
Andrew has 4x cubed plus 9x squared plus 14x plus 21. Same? Same? Everybody else, same?
Yes.
Okay. G prime of x is equal to the first times the derivative of the second. Remember, the derivative of x plus 3 is a line with a slope of 1, so therefore its derivative is just plain old 1. Plus the derivative of the first, 3x squared plus 7, times the second, x plus, that's supposed to be a plus sign.
Does it matter if you do the derivative of the first times the second plus?
No. The reason it doesn't matter is the only difference is you're going to have that first
Yeah.
and that second. It's the same, a plus b, same thing as b plus a. And that's how I always do it. I always take the derivative of the first times the second, but
Okay.
it's the same. I'm not going to multiply it out because I'm assuming that you can all do that and add like terms. Now notice, our original function is a quartic, 4th degree. You all recognize that, right? So as I've mentioned in the past, when you take the derivative of a polynomial, it drops the degree 1. So after you multiply all that out, you should get a cubic, which many of you did get. Questions on that? All right, and the problem is, we haven't really gone over the power rule problem, so I'm assuming that you can do basic derivatives. Okay, you can take the derivative of x squared plus 7x, you can take the derivative of x plus 3. If you can't, it's going to require a little bit more practice on your part. Okay, now, we're going to do 2 steps here. We're going to find the derivative of that using the power rule, the product rule, and then you're going to take that answer and take the second derivative. In other words, do it again. Go ahead. I'm going to talk while you're working. One of the more challenging things with the product rule is recognizing the fact that that function, p of x, is actually 2 functions, x and e to the x. It's a product of 2 functions. So in other words, x is your first, e to the x is your second. First, second.
I maybe x minus 1. So it's x.
It's e to the x, right? That's the answer.
I have no idea.
Because this
I
is
mean, like that's the
the
answer.
first is x.
What's the derivative of the second?
Then this is the
I had
derivative
that because even e to the x, the derivative is e to the x.
Oh yeah. What?
So derivative of the x
Oh.
take the x. So it should be.
What's e to the x?
All right.
I just don't know how to get it.
Times so then
Using this
plus
Oh, I see you added that line.
Yeah. I currently have that.
I think I just did this.
plus I
Its own derivative. It's that weird.
So it's like the derivative. Derivative of the first and the second. I draw like that.
So I have 2 e to the x times the function. Which makes f equal to percent.
Going on to this. G of, so e to the x is e of x. That plus both of them.
Okay, how'd I do for P prime? We're good? Now, eventually, as I mentioned on Monday, I know where we're going. Eventually what we're going to do is we're going to take this, and we're not going to leave it like this. We're going to turn this into e to the x times 1 plus x. Okay, but this is later. And I'm almost sure none of you did this. You just attack this beast to find the second derivative. Derivative of e to the x is itself, and then we just did this. So I'm not going to do it again. I'm just going to copy down that answer. And then again, at some point, we're going to do this to get that. Okay, problems? Recognizing that that's a product rule, step number 1. Remembering that the derivative of e to the x is itself, number 2. And then, obviously, understanding the product rule is number 3. And then, reiterating, you don't need to do this yet. However, knowing Everett, he's probably putting the answers on the answer keys matching these. So just so you recognize, if you have this, doesn't necessarily mean you got it wrong. You just didn't take it that extra step. Okay? Well, before we move on, are we good? Because the quotient rule is quite a bit more difficult. Going once, going twice, we're sold? Excellent. Okay. Now, before I dive into the quotient rule, I will tell you that I hate the quotient rule. You'll see why in a couple minutes. So whenever possible, I turn a quotient rule problem into a product rule problem. So for instance, if I just make some function up, let's say k of x, x squared plus 1 over x minus 3 squared, that would be a quotient rule if I'm taking the derivative of k to the x. I do it differently in that I turn k to the x, or k of x, I should say, into this. Okay, does that make sense? But we don't know how to do that yet. That requires something else. So eventually, after next week's lesson, you'll be able to do that. And then you can also decide, would you rather do it the way Reedy's doing it, or would you rather just stay with the good old quotient rule? It's doable, I just find it to be bothersome. Okay, so what's the quotient rule? Well, there it is. That probably doesn't make any sense to you whatsoever. However, on your slideshow, do this, please. Put brackets around that last chunk of stuff after the minus sign. Very important. And here's why this is why the quotient rule is a pain. When we're doing the product rule, I did it one time and then I switched the order. And then Andrew asked me, is it okay to switch the order? The answer was yes. You cannot switch the order in the quotient rule because of the minus sign. Remember, a minus b is not the same thing as b minus a. However, a plus b, same thing as b plus a. Okay, well, what does that mean in English? I'll show you how I do it which makes sense in my brain. If you just want to memorize, great. I'm not a big fan of memorizing. The way I learned to do it is the following. Excuse me. Oh boy. Hold please. Remember years ago when you would start coughing, you would announce to everybody it's not COVID? Those were big times, weren't they? When you're on Zoom all day long and you just wanted to never leave your room again and order in burritos. I hope that never goes back. Okay, anyway. Quotient rule. Y prime equals. I start with a big gazinta bar. I take the denominator, I put it in the denominator, and I square it. I take the denominator, and I move it up top. That gets me what I need to proceed through the rest of the problem. Because once I have that denominator up on top, then I know it's denominator times the derivative of the numerator, minus, big honkin' bracket, reverse it. The numerator times the derivative of the denominator. Okay, let me give you that again. Put the denominator on the bottom and square it. Bring the denominator up to the top. Denominator times derivative of numerator minus numerator times derivative of denominator. Missed a parentheses.
You should like write this out. On the thing.
On what thing?
On the notes.
What is it you want me to write out?
No,
The solution?
no, like what you just said.
I did, it's right there.
That's not on me.
Oh, you wanted in the verbiage that I used?
Yes.
Okay, I'm sorry. Would you like me to say it again so you can make sure you have it?
No, I think I'll just.
Okay.
He's a big guy.
There's a little note down at the bottom. Always simplify numerators. Do not touch the denominators. You're going to be tempted. Like, you're probably not tempted to square x squared plus 1, but when the denominators get a little bit easier, you might be thinking to yourself, sure, I'm just going to go, no, don't touch the denominators. What I do need to do, however, is simplify this numerator. Now, why do we simplify the numerators? It is fairly common that when you simplify the numerators, you might get some canceling. Okay? In this case, we won't get any canceling. But in the future, you might. The last thing you want to do is ask yourself, does that numerator factor at all in order to be able to cancel? Even if it does factor, nothing's going to cancel, so I'm done, and that's my final answer. Questions? You're up. Go. By the way, while you're working, what's the derivative of 9? 0. Good.
Yeah, and then you take the natural log of it. And then you're going to bring it. negative 1 equals to.
I don't think so.
Oh, yeah, wait,
Okay, I don't know if I'm right, but I haven't.
Do you write a little bigger so we can see?
I can't.
Please. Thank you.
Guys, I'm negative 9 inches. Did you get your answer? Negative 9 inches.
Yeah.
Where'd you get negative 9x?
I think.
Hey, did you get something wrong?
Oh my god. Literally is doing it wrong?
I think. That's
Yes.
that's
Oh, wait, you're just.
Yeah, I'm on the
Oh,
right track.
no wonder. Oh,
because I think
so negative 2. That makes a lot more sense. Alright,
yeah. 54.
So you take out the 18.
Yeah, so you take out 3. No, shit, no, 18.
We'll see.
Yeah.
Stick it to the front of the board. Just see a little rectangle there? There you go. Okay, let's give it up for me.
I got that.
So this is one of the things I find fascinating, which has absolutely nothing to do with calculus right now. Draw an X on your iPad. Think about how you're drawing that X. How are you doing it? Do you start? Here's how I do it. I start upper left down to lower right, upper right down to lower left.
I go upper right.
Upper right.
No.
Okay, so hold on.
I should have an X in my left.
I do it this way.
No, I go right.
Nah.
You go right,
Yeah.
then you down on both.
Yeah.
Does anybody go down then up?
I go
Yeah, Chris, down and up.
But you're right-handed. I'm left-handed.
So left-handed, you go down both.
Yeah, you're left.
Right. Mia, how did you do it?
Top left to bottom right.
And then
Oh, she's.
top right, bottom left, same way I do it?
Yeah.
Good. Okay, now draw 9.
Oh.
I had to think about this one. I do a circle and then down, right? Circle and down?
No, I insert like.
No, it's all, well, hold on.
It looks.
No, it's all the same thing. Okay, how about an 8? Do you do a snowman or an infinity on its head?
Infinity on its head.
I change it up. Most of the time I'm in infinity on its head, but occasionally I'll do the snowman.
No, I've never. No.
Never snowman? Does anybody snowman Yates?
Oh.
Thank you. I knew I had some friends over there.
I'm doing this this week.
Again, this has absolutely nothing to do with what we're talking about, but I was fascinated watching people write on the board. Okay. Nope. Okay.
Hey.
So let's go back to the product rule.
Man, I got the answer.
And you'll notice that in this one, I didn't tell you what method to use. You pretty much have two. You can either multiply it out and use the power rule, or you could use the product rule. Pick one and do it. How could the answer be not do it?
Oh, yeah, obviously. I don't think
To do the product rule, they don't have to be like polynomials. Like, can you like do it like with the 3 and 1 and I forgot what's on that.
The terms?
Yes.
I don't know if I follow what you're asking.
So like, can you still do it with like the 2 and this?
Yeah, oh yeah. Yeah, it doesn't matter how many terms are in. Yeah, you just need a minus 1. Because the derivative of x, negative x is negative 1.
Yeah.
And 9 disappears, then you do the other one.
Yeah.
Yeah, it doesn't matter how many terms are in there. I just typically use binomials because they're easier. Okay, stop for a second. Who multiplied it out? Nobody. Interesting. Okay, carry on. Let's go. I got this already.
Wow.
I got no work.
First.
My answer right?
Yeah.
That is right? Okay.
And B lunch. B lunch is horrendous.
Oh, it's terrible. So it's fun.
She said B lunch.
Yeah.
What are A lunchers then?
Yes.
Yeah.
That loses the, shouldn't it be like A lunch awesome or
Oh, no, I don't
A lunch aardvark?
Awesome.
Awesome.
So you're like you're prejudiced against B lunch?
Yep.
Okay. So you're allowed to say a product. For those of you that use the product rule, which seems to be all of you, you will notice that you still have to do some multiplying out at the end. So by multiplying out at the beginning, you're just reversing the process. I multiplied it out, then took the derivative, no more multiplying out required, whereas if you do the derivative using product rule, you have to multiply it out at the end. It's hard to, question.
If you were to like, okay. If you were to like simplify the 4x squared minus x times 9 into like, so you had like 3 separate, you just look at the product rule.
Ooh, great question. Let me rephrase your question to make sure I understand you. You're asking me how I would do something like this?
Oh, got it.
Yes.
Oh, that's a great question. Let's move on. I'm not going to answer that for you because you're going to play with that later. Okay. That is a summary of all the derivative rules we've done already. First one, derivative of a constant is 0. Second one, the importante, the power rule. Third one, that stupid thing that e to the x is its own derivative. The next row, times a multiplier or a constant is the same thing as the derivative times the constant. Then we got the sums, then we got the difference, then we got the product rule, then we got the quotient. There's one more we're missing, which is gonna fill in that gap right there, and that comes next week. It's called the chain rule. It's not fun. Okay? Now we take it to the next step. And the next step is equations of tangent lines. So, refreshing your memory, what are the two things you need for the equation of a line? Point and a slope. I got a point. 1, 0. How do I find the slope? Find the derivative. Now, here's the nice thing about this problem. You can see already that when you do the quotient rule here, it's going to get fairly ugly. You don't need to simplify anything. Why? After I find the derivative, what am I going to do? Plug in what?
Plug and chug.
Plug in 1, correct. Okay. Just like these other problems, if I go back one, where is it? This one, I could have stopped. That's a bad example. Where's the other one? Could have stopped here and just plugged in a value if I know what that point is. Okay. So knowing that, go ahead and solve that, please.
Basically just plug in 1 first.
It's fun.
Bottom square, hold on, you got the bottom up there, times the derivative of the numerator.
Yeah.
Now erase. Checking your voice, you're going crazy erasing. So that's the derivative of the bottom. Derivative of the bottom would be 2x plus 1. Where you don't have to use the number two.
Yeah.
Cool. All right, good. Now what? Or what? Good, good. Bryce, catch. You're up. Okay, while Bryce is writing his problem on the board, be sure to do a handwriting analysis to see how he's writing his numbers. If he's doing anything freaky, you can make fun of him with.
So basically, what you do.
Look at me in that moment. You don't see it until tomorrow. We're not going to do it Friday because we're going to be schlups are going today. We'll be ready for it Friday and then I stay off on Monday. Not Independence Day. So I would normally see you on Tuesday, but we had a day off, so this would be Wednesday.
1 minus 1 should have also been.
What?
Times
Oh my
2
god,
is
this
times,
is.
right? And then 1 minus 1 is
square
0.
to
It
zero.
should be 0.
Yeah.
So 10 minus 0 is 10. Also,
Wait, did you boil out one plus one? This one?
Yeah.
Yeah.
Hold on there, Hoss. I don't know. Did he do anything wrong? Is it 2 thirds? It is 2 thirds. Jacqueline, you sure? What does the problem ask you to do?
Oh.
Write the equation of line.
Oh, my fault, my fault. You may mess it up, Grace.
No. You stop what you're doing there. Yeah. I assume that says, what does that say in parentheses there after the 2 thirds?
X minus 1.
X minus 1?
Yeah.
Yeah.
Oh, okay, good.
What?
Get an X minus 1 out of that. Well, we'll go with it. Thank you. You're good.
Well, we just.
That's it.
Oh, okay. I thought it was.
So, sidebar here. I stopped Bryce because I think what he was going to do is start putting that in slope-intercept form, right? Yeah, don't do that. Okay. Point-slope form is your friend. Once you put it in point-slope form, leave it in point-slope form. There's this weird thing that if you have the answer and then you convert it into slope-intercept form, when you don't have to and you screw up on the math, you won't get full credit. So don't. Just leave it like that. Y minus 0 equals 2 thirds times quantity x minus 1. Beautiful. Well done. Okay? So that's the advantage of when you're doing the equation with tangent line, you don't have to simplify it. You can see how ugly that numerator is and how much of a pain in the butt it would be to simplify it. But again, we don't need to. The other comment I would make is not to start developing bad habits. By that I mean everything should be labeled. What is that? That's the derivative of f and should match that. It seems like I'm being overly picky, but it's relevant and it's a habit that you want to develop now so that you don't screw it up later on the AP test. And in fact, if we want to get a little fancier, we could say f prime of 1 is equal to that. Or call it m, the slope. Something so that numbers aren't just flying out of nowhere. By writing this, you're telling the reader, i.e. the grader, yes, I know what I'm doing. I got this number by plugging 1 into the derivative. Okay? Problems? Okay. The only reason I'm mentioning this is so that you can get comfortable with the notation. That's fairly intimidating, but this is all the different ways that we would represent taking derivatives. We're mainly going to focus on the first line. We've seen that before. We've seen that before. We've seen that. I talked about this. This is a new one. Not very common, but it happens. The derivative of y with respect to x. And then as you move down that scale, it's all the other notations for doing derivatives. We will seldomly, if ever, go past this line. But you should still understand the notation. We're all done. Let me stop the recording here.